All right, hopefully you are familiar with what a secant is. The way I think about it is it's like a chord that's infinite. It passes through the circle in two places and then heads on forever in both directions. So in this diagram we have two different secants. These would continue on theoretically. I just didn't draw that on screen here. Uh, what we want to know here is that these secants intersect each other in a way that is similar to how chords do. But with the secants being on the outside of the circle intersecting, they're not intersecting in here. This is going to change a little bit of how that relationship works. What we're going to see is that the long length, so from C all the way out to A, we're going to take into account that whole length now. That times its smaller counterpart here, the CB, is going to actually equal the same sort of setup on the other one, from C to E, the long length, times from C to D, the short length. So an easy way to remember this, in my opinion, is when it's on the outside of the circle, notice all four of these little guys here utilize this point. So the only combinations you can have are from here out to there and from here over to here. I never worry about B to A or D to E. We may have to do some work with that along the way, but in general, we don't have to think about those too much. So this is our general structure here. Essentially, the long part times the little part on the outside of the circle equals the long part of the other one times its little part on the outside of the circle. So I've got an example prepared down here. We're just going to take a quick look at one type of problem you could see. One thing I'm going to note is that they often won't give you the whole length. So for this one, we're going to say, well, let's go ahead and go with this top line. We have a total length of 25. We want to add those two things together. I know that 25 times that little 5 is going to actually equal the whole length of this side. That's 6 plus x. Now in this case, it's unfortunate. It's an expression, so 6 plus x times the little piece that's on the outside up here. So this 25 comes from 20 plus 5. That's the whole length of this part. And the 6 plus x is adding these two pieces together to get the whole length there. The 5 and the 6 are just these outside pieces here. From there, well, we know 5 times 25 is 125. And then here we can do a little bit of distributive property stuff. So 6 times x is 6x. And 6 times 6 is 36. And then from here, this is a two-step equation. We're going to do 125 minus the 36 equals 6x. And then we're going to divide both sides by 6. So I'm just going to do it this way. I think if you're somebody who struggles with numbers a little bit or just doesn't like to do these things by hand, I wanted to show that if you have a good enough calculator, you can kind of just cheat a little bit, and instead of thinking too much about it, this is just to save you some effort, you can just do it this way. You can do 125 minus 36 in parentheses, all divided by 6. And there we go, we get about 14.8. Now as a note, if you wanted to, if they wanted this as a fraction, we could leave that as about 89 over 6, which does not look like it would reduce at all, so I'd kind of leave it there and I'd be okay. But just wanted to point out that the calculator can do a lot of that stuff for you. In fact, if you were working on one like what I have, you can even set it up as a fraction so that it looks a little bit cleaner and still gets you that same value. And notice, if you do that, it will actually give you the fractional form instead. And if you don't like that, there are ways you can convert these things to decimals if you want to. It works. There are a lot of different things you can do with the calculator. But I just wanted to show that. As far as the actual intersecting secants go, this is your basic setup. You take the whole length, multiply it by the tiny length on the outside, so that's this little guy here. It's equal to the whole length of the other one times its little length on the outside. And then for the rest of that, it's just your algebraic manipulation stuff.